Okay, all ready? So we'll do image formation by convex lens. Okay. Let's make 3 or 4 such sundry diagrams. And once you're done, we'll then proceed. Convex lens, focus, double of focus, primary, secondary on either sides.
Sir?
Yes, sir.
Sir, we also do 3 last class. So the time we only have to draw one more of another.
I didn't get you. Come again.
We draw 3 image.
Not we draw, we drew.
We have to do 3 like,
So that's what I'm saying. We will now do image formations.
so we have to draw another 4.
3 image formations we have done. Is it? No, that were only for the rules we did. The rule is a different thing. Image formation is a different thing. Hey, पढ़ा नहीं है तुम? गोली दे रहे हो. Image formation is a different thing. Shreya, what happened, Bitu? At 8:30, 40 seconds itself, you logged in into the class. I was enjoying steamed idlis with chutney and I saw, Shreya logged in. Prashchit. One day she saw match, so she thought that everything I should now do on time. Wow. Acha, these are image formation, right, bhai? These are not rules. What we did was rules. Okay? Make 1 or 2 at least. One is done. At least one is done. Chaliye. Let's start with the first one. Like you have a lipstick dentist case in concave mirror. That was very special. What was it? It is the only case where you get a virtual, erect, and magnified image. Same will be the case here. Same will be the position. Just that it will not be lipstick dentist now. It will be microscope, hand lens, or detective, whatever we call it. Right? When you go to grade 11, you will be studying microscope. Simple microscope is your hand lens, which we use, the magnifying glass. Right? So let's draw that criteria now. So I will make my objects with what you call green bar. So this is my object. Object is kept between focus and the optical center. Okay, bacha? Between, okay, mark these as O. O is your optical center. This is the only unique case. Everything will be like concave mirror, but this is the only unique case where we will get virtual, erect, and magnified image. Okay, so let me complete my object first. So this is the object AB, right? And how does the rays go? One ray which is parallel to the principal axis, it will pass through the focus after refraction. Okay, it will pass through the focus. Another ray which will pass through the optical center. Now diagrams need to be a little bit adjusted, children. I am not geometric. That will actually be going undeflected, and these two rays, make your diagram in such a manner that these two rays are actually divergent rays. Okay, my focuses are not exactly equal, right? So the image formation will be, these two rays will diverge out, children. These two rays will diverge out. Sorry, these two rays will diverge out, and there is no chance of them meeting in near future. So what we will do, we will extrapolate these rays and try to have the virtual image formation. We will try to have the virtual image formation. Okay, you may find it a little bit absurd, but it's like this. So this will be my virtual image which will be formed. So if this is A and this is B, our image is now A dash, B dash. Children, you should first write what is the position. Number one, we should write here when object is between F and O, that is the focus and the optical center, and mark this particular case specific because this is a unique case. Then you will get position, PNS, position, nature and size. What is the position? Position is on the same side of the lens of object, or you can say behind the lens, whatever you want to say. You can say behind the lens or on the same side of the object. Nature. Katak, katak, somebody's chopping nails or what? Tak, tak sound is coming. Nature. The nature will be erect and virtual. And what about the size? The size will be magnified. Special case. So since this is a special case, let's give our special things. The special things would be hand lens, okay, detective, then palmist. You know who is a palmist? Who looks at your hastarekha and does your bhavishyavani. So hand lens, detective, palmist, and this is also known as a simple microscope. Yes, sir. Yeah, there is nothing called F dash, is just to differentiate the focus. It's between focus and optical center. This is also focus, this is also, it's a lens, it's not a mirror. F dash is your convention to distinguish, but we say focus. There's a focus on this side, there's a focus on this side also. If you take the object beyond the focus, so magnifying glasses have got very large focal length, so that by mistake also if you're taking the object away, still it is within the focus and optical length, that is within the focal length. They will have large focal lengths. Otherwise, the moment you take it a little bit away or you take it a little bit inside, the object will invert. Clear? Shall we go to the next one now? The next one would be the Bua and the Mama story. Well, it will be object at infinity. Object at infinity. Object at infinity, you can draw two type of cases. In one case, we cannot show the size, the one which will be directly on the focus, and in another case, we'll take slanted. Then we can show a little bit small size and it will be on the focal plane. Okay. So when your object is at infinity, rays are what? Rays are distant, rays are always parallel. So distant rays are right now coming. Parallel distant rays are coming. These are all parallel distant rays which are coming from far off places, and they all will merge where? They all will merge at the focus. This is actually the definition of the principal focus of a convex lens. That's why this lens is also known as a converging lens, right? So please take a magnifying glass, get up early in the morning and try to look at the sun with it and kiss your eyes goodbye forever. Understood or not? So here what will be the position? The position will be at focus. What will be the nature? The nature will be real and inverted. Inverted we will see now how it is inverted. And then what about the size? Diminished. Here we use the word diminished. Diminished means almost non-existent, very, very small. Very, very small. In order to say that it is inverted, we will now damage one more diagram only for you. Only for you. Rays which are parallel are, sorry, parallel rays coming from far off objects. Far, far off. Right? Here we should have a concept of something which is called the focal plane. This is my focal plane. Now the image will be formed on the focal plane. Image will be formed on focal plane. And now you can actually sense that your image is highly diminished. This is your image. And the image will be ulta. Okay. This is, children, the same explanation of this. This is where we are showing that it is at focus. This was showing at focal plane. Now two cases will be what? Between 2f and f, beyond 2f. Like we were f and c, beyond c. So we will do that now. Again, there will be just replica image formations. Okay. Now first we'll do object at focus. Now our next one will be 3. Object at f or focus. Right? So the object will be now at focus. Object at focus. Object at focus. Ray parallel to principal axis passes through focus. And a ray through the optical center goes undeflected. Children, draw your diagram in such a manner that they appear parallel. The rays should appear parallel. So I've understood my mistake. So let me first make this ray. And then let me make another ray. All right. Which is they will become parallel rays. So here the position will be at infinity, just opposite of that. Image formation will be at infinity. Nature, real, inverted. Size, highly magnified. Size will be highly magnified. Just like concave mirror, no change. अमिता अभी इजी होना शुरू हो गया, कोई टेंशन नहीं. चेंज करूं मैं इसको? Shall I change the screen? We need to draw 2 more templates. Okay, children, I'm changing. If you get stuck up, tell me. Otherwise, I would always love that you are able to do on your own. So I'm just changing. If you get stuck up, don't hesitate. Just call, give me a shout, and I will do that. 1, 2, 3. 3 we have done, right? Fourth. ठीक है ना बेटा? No, not 4. This is the same case. Yeah, this is 2A. You can say this as 2B. This is just illustration how to say. So we've done 3. Shall we? Now on a fourth, object is between F and 2F. F and 2F means image will be formed beyond 2F and the image will be a real magnified. Anything beyond 2F is magnified and we'll put the object beyond 2F, उल्टा फॉर्म हो जाएगा उसका. इसी का मिरर इमेज ये बनेगा, है ना? The same thing. चलो. Let's take our object. Object is between F and 2F. So this is my object. नन्ना सा, प्यारा सा, बच्चा सा. Ray parallel to principal axis is going to pass through the focus. And another ray through the optical center will intersect right here beyond 2F. So my image formation will be out here. If this is A and this is B, then this is A dash, B dash. क्या हो गया? अरे तुम्हारा माइक कौन है? तुमने अरे बोला वो हमने सुन लिया. ठीक है? Position beyond 2F. Nature is real and inverted. Size magnified. Understood? Size is magnified. Very good. Fifth one. Object beyond 2F. The object is beyond 2F. So let's see. Object is beyond 2F. Ray parallel to the principal axis is going to pass through the focus. Another ray from the optical center passes undeflected. As a result, image will be formed between F and 2F and the image size will be smaller. This is A, this is B, this is B dash, this is A dash. Anna? So what do we write? Position between F and 2F. These are just opposite of each other. Between F and 2F. Okay. Nature. Nature is real. Inverted. See, life has become so easy now. Size smaller. Smaller than object. Clear? Before going to numericals, we'll also discuss some of the uses of this lens. This lens is used. Okay, लिखते जाओ. कर लो, पहले कर लो. Then. Oh, Veda is also there. In some part of India, between some latitude and longitude, she's there. So tell me, is image formation now getting clearer? Once you know mirrors, you cannot do a mistake out here. Like in mirror, you have a special case, you have a special case here also. Applications of which are seen in by as hand lens or simple microscope. So some case-based question, if they say a palmist wants to read the palm lines of a person, then in that case they are referring to a convex lens. Done. So uses of such lenses, number one, are used for making hand lenses. Many optical instruments like telescope, microscope, these lenses will be used wherever magnification. Also used for correcting hypermetropia. Myopia, hypermetropia. That you will get clear once we study hypermetropia. Hypermetropia means far-sightedness. Far ko dekh sakte ho. Far I can sight. My problem. If somebody tells me, can you see your mobile? I can't. Can you see? Yes. What is your problem? Can you see the mobile? Yes. Can you read the blackboard? No. So it is used for. So लिख लेते हैं थोड़ा सा. Uses. Uses of such lenses are usually seen in optical instruments. And these optical instruments can be, number one, camera, telescope, okay, microscope, binoculars, whatever you wish here, keep writing. Binoculars. Then they can be used for spectacles, hand lens, and spectacle, since you are grade 10, you write to correct hypermetropia. Hypermetropia. What is all this? We will study when we study human eye and the beautiful world. Hypermetropia. Yeah.
Hypermetropia different.
Is hypermetropia and
Hyperopia different.
okay? Can you tell me what are the rules for image formation by a convex mirror?
Convex mirror.
Yes. Convex mirror. See, MTV multiband. So please study what is there in syllabus. Asking something which is not in syllabus is less of curiosity and more of derailing classes, which is not required. What is important, you are not reading that. Eat the banana, not the peel. Sometimes children are more interested in licking that circular pack of cornetto cone. That is only momentary happiness. Little bit of ice cream will be there. Please concentrate on eating the cornetto cone. Yo man. Such a nonsense teacher. See, I ask him something, he will always say something wrong. खाली कीड़ा करना रहता है इसको. ठीक है? We have it. अनन्या, एक हेल्प करोगे? वो रूम जाओगे, उसमें देखना खड़ा खड़ा खड़ा. From the right to this side, you will see a yellow colored physics लक्ष्मी सिंह. येलो कलर में रहेगा. जरा ले आइए ना. देखते मिल जाएगा आपको. Any questions on the images? There's one more. Which one? At 2F is pending. Yes. At 2F, we will get the same size. Can you start making it? At 2F is similar to at C. Ananya, bito mila? Just check. At 2F, thank you so much. Sorry for the trouble. We missed one. At 2F. At 2F will be just like the one which we did for mirrors. Okay, very good. Thank you for reminding me. Object at 2F. But we will make it. What is the issue? She has asked for it. She never asked for anything. How can I deny her? बना दो, क्या जाता है? Same case. So ray parallel to principal axis passes through the focus, and ray through the optical center. Oh, my diagram is not correct, huh? So I'll do some cheating, which you are not allowed to do. And my cheating is very simple. So this is now this is also my 2f. The image will be formed at 2f, inverted and same size. Right? So this is object at 2f. Right? Then position of the image will be at 2f. Nature is real, inverted, and the size will be same as object. What is important for you all to understand now is that when numericals are given to you, try to estimate the answer before doing the numerical so that you know whether your answer is coming in the right range or not. Okay? Do you want me to revise sign convention once again? I can. I have no issue. If any child wants me, sign convention, फिर से एक बार, ठीक है, no issues. Our next topic for discussion would be sign convention. Sign convention. I am making it a combo diagram. You all are senior enough now to understand. I'm making a combo diagram. I'll make one for convex, one for concave also. Okay. So can we start sign convention? Concave lens, convex lens. Number one, object will always be placed on the left hand side. Sir, can I not place on right hand side? You can. But the convention is we place it on the left hand side. And remember, one small rule. All measurements along the direction of incident ray are positive. All measurements along the direction of incident ray are positives. Now, first question comes, sir, then which side are our incident rays? Children, our incident rays are always from this side. The incident ray, whether you are doing a convex lens problem or a concave lens problem, the incident ray is always from LHS to RHS. Is this thing clear? The incident ray is from LHS to RHS, and every measurement that you make along the direction of the incident ray is always positive, or you can go by the graph quadrant. Now let us talk about the convex lens. The convex lens has a focus which will be on this particular side, right? And this distance is known as what? This distance is the focal length. This distance, sorry, it becomes bad. So this distance is the focal length. Yes or no? This is the focal length. Sorry. This is my focal length. And when I look at a concave mirror, the focal length, the focus is on this side. This is my F. So this is my focal length. So this is something that you have to be extremely careful when you are doing problem on lenses, right? So this F is being measured. Now, how are you measuring? All distances are measured from the optical center, which is your origin. You will measure the distances always, whether going measuring up, measuring down, measuring left, measuring right. The starting point is always the optical center. So if you measure the focal length of a convex lens, you're measuring on right side. So in convex lens, the F is always taken as positive. Is this understood by everyone? Have you understood this logic? Right? At least say a yes or a no, or put your hands up also. This is positive. And when you see the measurement of focal length on this side, then the focal length is being measured on the side which is opposite to the incident ray, or you can assume that you're going on negative axis. So here the F will be always negative. Understood? Our next thing comes is the measurement of object distance. The object will always be on left hand side. So the object distance, wherever is your object, whether it is this type of a lens or this type of a lens, the object distance is always negative. The object distance is u, which is always negative. U is always negative, which means if the data for the problem is given, you will take it as negative. If somebody is asking you to calculate u, just leave it. Automatically it will come out in negative. You did not take it as minus u. Did you understand? If the data is given to you, suppose they say object is placed at 15 centimeter, you will take the object as distance as negative 15. But if somebody says find the object distance, then you don't massage the u, you just leave it. It will puke the right answer if everything has been correct. Right? Okay. If we see the case, just now we saw all the image formation in the case of image formations in the case of what? In the case of convex mirror. In the case of convex mirror, when you are using as a hand lens, be very careful. Your image is formed on which side beta? When I'm using it as a hand lens, my image is formed on this side. Agreed or not? Right? In that particular case, my image will be, distance will be negative. Rest all other cases, my image distance would be positive. Right? My image distance would be positive. B would be positive. This is for hand lens. Okay? Now we come to something called object height. And object height is always measured from the optical center. So the object height is always something which is positive. Whether you are on this side, this type of a lens, or you are on this type of a lens, the object height HO is always positive. HO is always positive. Understood? And in this particular case of a hand lens, I will get a very bigger object height, something like this. This object height, HI, will be positive. Rest all are real. That's why I'm making it with a, so rest all HI will be negative. Very common sense, nothing more than that. All will be negative. Got it?
Yes, sir.
Now, concave, though we have not discussed any case, in concave, all images are erect. So in concave, every time HI will be positive. You all are wearing concave lenses. Do you see anybody ulta, irrespective of whatever distance they are? No. Or apply common sense always. Then you might say, sir, you should see everybody ulta because you are wearing convex. Except one case, I should see everyone inverted, right? But my lens focal length is adjusted such that the focal length is extremely large. Because it was small focal length, he would have been placed where? Beyond focus. So I would have seen him this way. I don't see him that way. Are we fine? Okay, couple of some formula issues. I told you at the beginning, at that time maybe you did not understand. Lens has the word E, and so is the word negative also has E. Clear? So the formula always becomes minus formula. Mirror has I, addition has I bandar ka bhai. So this is E. So here my formula will be 1 upon F is equal to, which one should come first? In India, it is always VIP culture. V comes first. And V stands for VI. image. So 1 upon V minus 1 upon U. This will be my lens formula, also known as the thin lens formula later on. And magnification here becomes V upon U. That negative goes away and also can be written as the height of the image over the height of the object. Two things to be taken care of. Negative comes here, negative goes away here. Negative goes away here. It's just height of the image over height of the object. Maybe your handwriting is not so good. So let us make it a little bit good. HI over HO. And now all those iterations you know. In this case, what should be the value of magnification? Value should be positive and the value should be more than 1. And at 2f, the value will be negative and equal to 1. And rest all other cases, magnification will always be negative. Negative because the object height is always negative. Clear? Anyone, any doubt out here and you want me to explain again, please do not hesitate, because if you hesitate here, you are kissing 5 marks goodbye in your exam. 5 to 4 marks question will come from here. See it. I will give you a strategic timeout of 30 seconds. And in 30 seconds, just watch. If there is anything that you don't understand, you want me to repeat, I have no objections at all. All okay? Very nice. Chaliye. We have some time, so we'll do some problems. The course khatam hone ko hi aa gaya. After this, we'll do human eye and the beautiful world. Instead of going to human eye and beautiful world, we'll keep it. We'll start electricity, because human eye and beautiful world is a very cutie chapter, right? If we do electricity, it will help those guys also. Who? The thumb biter. Yes, thumb biter. Thumb biter will get some help if we do electricity. So chale, kuch problems karte hain? Haan sir, aaj, no, today you were eating something with a ball and spoon, which was a very lovely sight to watch, that you are eating edible items.